Morning, integrated math superstars. Thank you for coming back for this second video in this module. I appreciate that. You might notice a small change in the classroom here. I'll leave that up to you to find it if you've been tuning in consistently. What's on the agenda for today? A quick refresher on how you should be working through these videos and what's expected of you. If you've watched the first video, you already know a few things. I just want to reiterate those so that you don't forget. We'll continue with 1.3 examples dealing with geometric sequences. Should be pretty simple, if you're working hard, of course. While watching these videos, of course, remember, copy down all of the work that's shown and completed. Use the resources on Blackboard if you'd like to print an outline. Make sure to pause and rewind if you're stuck on anything or need to hear something one more time. Sounds good? All right. So with this section 1.3, we saw more dots were added. We saw that their behavior was growing in a different way where it's not just adding 2 and adding 2 and adding 2. We see that that changes up a little bit here. So for this first bit, the ready, we're going to be interpreting function notation, which is something we've seen before, but now we're going to be working with terms that are looking at n minus 1 or n plus 1 or n plus 3 as far as the step, which isn't too bad. We really just have to look at the information that's given to us, and we have this table here to help us out. So we're being asked to use the given table, identify the indicated value for n, then use the value for n that you determined in A, and then use the table to find the indicated value for B. So problem B. All right, let's do problem 1, definitely. And we'll also try problem 4. All right, so this is saying that when f of n equals 12, what is the value of n? Do you see any 12s in the table here? Well, I know that it's claiming when f of n equals 12, so I would only be looking at this bottom part here. And I know it's not this, not that, not that, not that. And I see here we have 12. So what's the n value when f of n equals 12? Hopefully you're saying 5. So we know that's 5 for n. And then what's the value of f of n minus 1? Well, let's imagine that if we were to put 5 in place of n, we would have 5 minus 1. Can we simplify what's in parentheses? Hopefully you're saying 5 minus 1 would get you 4. And then f of 4, well, I know that the input's 4, so the outcome here is 7. So that's our answer. Now I'll write this again over to the side. So for 1a, it was 5. For 1b, it was 7. If you want to challenge yourself, try the next one on your own. Pause the video, give it a shot. Okay, hopefully you tried it. And with 4a, we're finding when f of n equals 2, the value of n that's produced from that. So I know that I'm down here on this second row again, and I am aiming to find where the outcome is 2. So I know that occurs here. So that means my input was 3. And if I'm looking for the value of f of n plus 3, let's imagine again that I were to plug in 3, so this 3 in place of this n. And if we were to take this further, this would give f of 6. So what's f of 6 going to be? Well, then put 6, the output's 17, so it's 17. Pretty simple. Really comes down to using the table that's up here, and knowing what it means if n is given or if f of n is given, and then working backwards. Sounds good? Let's keep it going. For our set, we're comparing explicit and recursive equations. We've seen these now twice, so let's see what's going on here. Use the given information to decide which equation will be the easiest to use to find the indicated value, find the value, and explain your choice. Okay, so we have different versions of our equation. We have the recursive, which is a little bit more wordy. There's nothing wrong with that. And the explicit equation, y equals 3x plus 7. So let's see. If we're finding the indicated value, what do you think? Well, you honestly have a few ways you could approach this. Of course, one's going to be easier than the other. Personally, I think the recursive is the easiest because I don't have to plug in a ton of information. This is saying that the now term, which in this case is 4, so 4 is our now, is equal to the previous term, so 16, and then adding 3. Pretty simple. Explanation, well, I didn't have to plug into the equation up here for x, even though I could have. I simply just added 3. So I would say it's easier to add 3 instead of taking y equals 3 times 3 plus 7. Oh, I should actually write the right number in, right? Instead of just adding 3. Okay, so 16 plus 3. Hopefully you saw that blooper. And you knew it was wrong, okay? So in this case, the fourth value is 19. And our reasoning still is good. I'll leave that next one up to you. This is more of the same. Well, let's see if we can find one where it makes more sense to plug in, okay? So let's try 11. So the value of the fourth term is 80. The sequence is being doubled at each step. So let's make a table. Let's say we have x, we have y. Hopefully we've made a few of these tables now. So the value of the fourth term is 80. The sequence is being doubled at each step. So as we move forward, this is multiplying with 2. If we were to move backwards, it'd still be multiplying by 2, but how do you think we can move backwards to this? Because originally we multiply forwards, but if we're now going backwards, we could take half of that. So if we do 80 over 2, that's 40. And then just keep taking half of that term to go backwards. And this isn't necessarily working to help find the fifth term, but it's all good. It's good to fill this in as much as you can. That's what you should be challenging yourself to do as you move through all of these problems. So half of 40 is going to be 20. Half of 20 is going to be 10. Okay, so if we're finding the fifth term, 80 times 2, 160. Because remember, we keep multiplying 2 as we move to the right. But if we move to the left, we're dividing. So 160. Explanation. I don't know, what do you think? Why do you think this one's easier? To use the recursive. I'd say that you don't have to worry about exponents. So in this, we didn't need exponents. And we didn't necessarily need other terms. We didn't need to multiply with 5. think that those are good reasons as to why the recursive is a little bit easier to use. Hopefully you agree with me. And let's see what's up with the go. We have these exponential equations. We're evaluating them and organizing our inputs. Okay, that's not too bad. Let's do 13, and we'll do a -1. All right, so this one's pretty simple. Honestly, you're just plugging in for where x is. Do you think you can do it? I think you can. So let's knock this out. All right, so our first equation is y equals 4x. Our input's 1. So what? 4 to the first power. It's just 4. 4 squared. Can you rewrite that? You can. It's just 4 times 4. 4 times 4 is 16. 4 cubed. We have 3 versions of 4. So 64. I'll leave the next 2 up to you. And with 14, y equals -3x. Notice we're in parentheses here. This is where I see students trip up a ton. I don't think you're going to be that student though, because you know that I'm going to walk you through this. So a lot of students will just disregard the parentheses for one reason or another, but with exponents, you have to be very careful. So instead of x, I'm going to put 1. -3 to the first power is just -3. And then if I have -3 in parentheses being squared, how can I rewrite that? What does that look like if I were to draw it out? Hopefully you're saying -3 multiplying with -3 again. Negative times a negative gets me what? Hopefully you're saying a positive. And then 3 times 3 gets you 9. And so you'll start to notice these are going to alternate between negative, positive, negative, because we keep going back and forth between the outcomes of some numbers move together and become positive, but then they have another negative number. If you expand some of these, you'll see it happen. And let's see. This would be negative, definitely, because we're taking -3, cubing it. -3, -3, -3. Well, I know that -3 times -3 was +9 from the first, or the most recent input, which leaves one more -3. Positive times the negative is positive. Psych, it's negative. Tricked you there. And 9 times 3 is 27. So that's our input here. I'll leave the other 2 up to you. I hope that this video was helpful. If you have any questions, reach out. Thanks for watching.